Everything you see right now, this screen, your hands, the room around you, might not be real. Not in the way philosophers debate it, literally, like lines of code running on a machine. Physicists have found something buried inside the mathematics of reality, something that should not be there. A structure, a limit, a resolution, like pixels on a screen that you can't zoom past. And once you understand what that means, you will never look at reality the same way again. In 2003, a philosopher named Nick Bostrom published a paper that quietly shook the academic world. It was called, "Are You Living in a Computer Simulation?" And it wasn't a thought experiment. It was a logical argument, a proof. Bostrom argued that one of three things must be true. Either civilizations always destroy themselves before becoming advanced enough to run simulations, or advanced civilizations simply choose never to run simulations. Or, and this is the disturbing one, we are almost certainly already inside one. The logic is simple but brutal. If simulations are possible, and civilizations eventually run billions of them, then the simulated far outnumber the real. Pick a mind at random from all minds that have ever existed, and the odds are overwhelming that it lives inside a simulation. Bostrom didn't say we are in a simulation. He said the mathematics makes it the most probable scenario. That paper became one of the most cited in modern philosophy. And then the physicists started paying attention, because they had already been finding something strange in their own equations, something that looked less like nature and more like code. Start with the Planck length, the smallest unit of distance that physics says can exist. It is 1.6 times 10 to the power of negative 35 meters, a trillion times smaller than a proton. Below that length, distance loses all meaning. Physics just stops working. To simulation theorists, this looks exactly like the resolution limit of a rendered universe, the point at which the programmer stopped rendering detail. Then there is quantum mechanics, the science of the very small. At the quantum scale, particles don't have definite positions. They exist as smeared clouds of probability, every possible location at once. But the moment you observe a particle, the moment it is measured, it snaps to a single definite location. Physicists call this wave function collapse, one of the most baffling phenomena in all of science. A simulation theorist looks at this and sees something else entirely: lazy rendering. In modern video games, engines only fully render what the player's camera is pointing at. Everything else is left unresolved to save computing power. Quantum particles do precisely that. They remain unresolved until observed. The universe appears to be computing only what it needs to, exactly as an efficient simulation would. Then there is the most unsettling clue of all: the mathematical structure of the universe itself. Physicist Max Tegmark has argued that the universe is not described by mathematics. It is mathematics. Every particle has a precise charge, a precise mass, a precise spin, numbers that match to extraordinary decimal places. The laws of physics are written in the language of mathematics, not approximately, but exactly. Physicist Eugene Wigner called this the unreasonable effectiveness of mathematics, the inexplicable fact that abstract equations invented by humans perfectly describe physical reality. If you were designing a universe as a simulation, you would build it from mathematical rules, and we live in exactly such a universe. Then came the discovery that stopped physicists cold. In 2012, theoretical physicist Silas Bean found something buried inside quantum chromodynamics, the theory describing how quarks and gluons bind together to form matter. When physicists simulate nuclear forces on a computer grid, they impose a lattice, a minimum spacing between points. Bean's team discovered that the real universe appears to have exactly that kind of lattice, a physical grid underlying space itself. And the cosmic ray energy cutoff, the hard upper limit on particle energy, aligns perfectly with what you'd expect if space had a minimum pixel size. So what are we actually saying here? That somewhere, perhaps unimaginably far in the future, perhaps in another universe entirely, there is a civilization running a computer, and inside that computer, a universe runs with stars, planets, quarks, and conscious minds that have no idea they are processes in a program. The evidence isn't definitive, not yet, but the pieces keep assembling themselves into a picture that is difficult to dismiss. The Planck length, the pixel size of space, wave function collapse, reality only rendering when observed. The mathematical precision of physical laws, constants that look like parameters set by a designer, the lattice structure of space matching the architecture of a computational grid, and the cosmic ray energy cutoff, a hard ceiling on energy, as if the universe has a maximum integer value. Each one of these, alone, has a conventional physics explanation, but all of them together, pointing in the same direction, that is harder to wave away. Elon Musk has said the odds we are not in a simulation are 1 in a billion. Neil deGrasse Tyson put the probability at 50-50. The physicists who disagree are not dismissing the idea for scientific reasons. They are dismissing it because it is unfalsifiable. Unfalsifiable, meaning there is no experiment you could run inside the simulation that would definitively prove you are in one, because the simulation would simulate the result of every test you ran. There is, however, one theoretical way out. In 2012, Bean's team suggested that if the universe has a lattice structure, then cosmic rays arriving from certain directions should have a detectable bias, an anisotropy, aligned with the grid. In other words, the grid would leave a fingerprint. We don't yet have detectors sensitive enough to confirm or deny this, but the test exists. For the first time in history, we may have a way to check. Here is the thing that should stay with you. Even if we are inside a simulation, the love is real. The pain is real. The curiosity that made you watch this, real. The substrate of reality, whether matter or mathematics or code, doesn't change the weight of a human life. What the simulation hypothesis does, more than anything, is remind us how little we understand about the nature of existence. We have mapped galaxies billions of light years away. We have split the atom and traced the edges of time, and yet the most fundamental question, what is reality, actually, remains wide open. Maybe the universe is a program, or maybe reality is so strange, so deep, so astonishing, that the truth, when we finally find it, will make the simulation look like the boring answer.